Hello, welcome to Flipped. So today we are on the mole concept, and the mole is the basic unit in chemical calculation. We are all familiar with a pair of shoes, right? That means there's 2 pairs of shoes. Okay, what about 1 dozen of eggs? That just means there's 12 eggs here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Am I right? Then the shoes are just 2. What about 1 mole of CO2 gas? This just means that there are so many particles that we can't really count them. Okay, we can count them and they'll result in a number of 6 times 10 to the power of 23. Okay, that's 6 with 23 zeros. So that's a lot of particles. And that's why we like to use the word mole to simplify the calculation for us, so we don't have to use this number all the time. It's the same as why we use pair and dozen. It just simplifies the understanding of the number of stuffs that we are talking about. So this is the most important equation, in my opinion, in the whole syllabus, is the number of moles. Okay, it's basically taking mass in grams, this is very important, divided by the relative atomic mass, MR, or AR, which we will learn later. We'll learn about this in the later section, but let me just talk about the formula first. So this is the formula that's being given to us. I like to simplify it in this shorter version of it. Number of moles, I write this cursive N, and equals to mass over MR. This can be represented in this triangle here, with the grams on top, mole below, and MR at the side. So if I want mole, I just take, for example, I just cover it up more. I cover up the mole, and I can see that grams divided by MR gives me mole. What about if I want MR? Okay, I just cover up MR, and I can see that grams divided by mole gives me MR. What if I want grams? I just take mole times MR. It will give me grams. Okay, because side by side is multiply, top and bottom is divide. Okay, if this sounds very familiar to you, because it's adapted from this formula. Okay, hope you have learned before in primary school calculation. This is the DST, DST triangle, DST. D stands for distance, S stands for speed, T stands for time. Okay, hope it's coming back together. So if I want speed, for example, I cover up speed, okay, and take distance divided by time. On the other hand, if I want time, I just cover up time, distance divided by speed. If I want distance, I cover up distance, speed times time. Okay, and that is it for this DST triangle. So we merely adapted this triangle into our mole calculation, which means G, mole, and MR. Okay, hopefully this is clear. And this formula is very important, and it's not provided, so you have to memorize this. Okay, let's move on to some actual calculations. So these are examples of mole calculation. So first question I have here is calculate the number of moles in 30 grams of sodium. Okay, let me quickly write the formula. N equals to mass over AR. Okay, we'll talk about this AR and MR thing later. Okay, my mass I know is 30 grams. So I just write it here, 30 grams. My AR, how do I find it? It's actually here. This is my periodic table. I just extracted these 3 elements for you, and I always take the biggest number in the atom, in the element of interest. So in this case it's 23, so it's 30 divided by, I plug in 23 here. Okay, and this gives me a number of 1.30 mole, and this is my answer for the first one. What about second one? Calculate the number of moles in 2 kg of C2H4. This is ethene gas, which we learned about in organic chemistry. First of all, we know that the formula, okay, is this one, right? Let's not write the formula first, because this formula requires my mass to be in grams. So I have to write the first step is actually 2 kg gives me 2000 grams. And then I can do my formula. N equals to mass over MR in this case. Okay, we'll talk about the difference between MR and AR later. Okay, mass over MR gives me 2000 on top, divided by MR, which is the adding up all these elements. Okay, let me just show you with an example. C2H4 is, okay, so we talk about C is here, right? I take the biggest number of C. This is the mass of C, right? 12. So it's 12, but there's 2 C's, so I take times 2. Okay, what's next is H. I can see that the biggest mass of H is 1. Okay, it doesn't matter, because both are 1, but I take this one below here. And I plug in a 1 here, and there are 4 H's, so times 4. Okay, hopefully this makes sense. You can see that this below here is because 12 times 2 is because there's 2 C's here, and 1 times 4 is because there's 4 H's here, 1 times 4 to give us H4. And if you use calculator, this one will give you 34.5 mole. Okay, and this is the answer for calculate the moles in 2 kg of C2H4. Okay, this will be the answer respectively. Okay, so these are mole calculations, very easy. Let's talk about the difference between MR and AR, right? You keep seeing them here. It's here. Okay, MR and AR, are just relative masses. What do I mean? Because if we are talking about the mass of atom, which is very, very small, okay, and it's very tedious for calculation if you use something very small to do it all the time. Because remember, we are using mass, which is quite heavy, for example, 2 kg, 2000 grams, to divide by something that's extremely small. So it makes calculation very difficult. Instead, what we use is called AR or MR. Okay, let's start with AR. AR is called the relative atomic mass. Basically, it's for single atoms only. Like in the case of sodium that we saw just now is 23. Okay, basically this is the definition you have to remember for AR and MR. AR is defined as the average mass of one atom of that element compared with the mass of 1/12 of a carbon-12 atom. Okay, basically this is how they get the number here. Okay, 40 and 32 for example. And this one you have to memorize. Basically what we are talking about here is that we are using carbon-12 as a standard for everything to compare with. So we can give them a relative mass in the case of argon and sulfur, etc. Okay, so why we can use AR for argon is because argon is group 0. It's very stable on its own. Okay, it doesn't exist as AR2 or AR3 for example. It just exists as AR gas. So that's why we use AR for it. This is 40. Sodium is 23, we saw just now. Okay, that's why sodium also exists as its own. So it's just 23. On the other hand, this thing called relative molecular mass is more common, I would say, because it involves more than one atom. Because we know that most elements in the periodic table, they are unstable, so they rather form molecules rather than just atoms. Okay, so this is more common, I would say. Basically, it's defined as the average mass of one molecule of that substance compared with mass of 1/12 of carbon 12 atom. So it's the same as AR, but now we're talking about molecules of substance versus atoms of the element. So it's a bit different, and you have to memorize this as well. Basically, we are using carbon-12 as a standard again to get the mass of each atom. So let me just use example to illustrate it more clearly. So for example, C2H4, I know there's 2 C's, so I know my C is 12, okay, as per previous example. 12 times 2, okay, plus, I know my H is 1 times 4, okay, I add them up is 58. In the case of H2SO4, I know I have 2 H's, 1 times 2, 1S, 32, here, right, the biggest number. Okay, so it's 32, plus O is 16, okay, I didn't put it here, but you check the periodic table, it should be 16, times 4, okay, because there's 4 O's, and it will give me a total of 98. Okay, so what's the difference between this is that you can see that in AR, I just take the number directly from the periodic table, whereas for MR, I have to take the periodic table numbers and add them up with, multiply them, for example, add them up with other atoms. Okay, so this is the difference, because MR has more than one atom, whereas AR has only one atom. Okay, and that will sum up the mole concept and the relative masses.